Today we're going to talk about positron, electron, beta decay, gamma particles, um, beta particles, alpha particles. But before all of that, let's talk about nuclide. So nuclide, I do not know if I'm pronouncing it right, but I think it's nuclide. This is where we can see the nucleus of an atom. This is a term used to describe the nucleus of the atom. So this A is the mass number, X is going to be the element. I'm gonna put some, you can take notes. So this is the element symbol, and Z will become the number of protons or the atomic number. Now let's solve some practice problems. What element will be produced if carbon-14 undergoes beta decay? So carbon-14 is just basically the isotope of our standard carbon, which is carbon-12. So it does have a mass of 14, and carbon-14 will now undergo beta decay. So beta decay is basically this thing. It is massless, but it does have an electron. So this is, you can write this as electron. So solving for this, the answer is going to be nitrogen. Now let's give the name of each particles. So this in Y, that is also a Greek symbol. That is a gamma particle. It does have a zero atomic number and zero mass. So this is a proton, this is a neutron, neutral, and this is a positron, which is an antimatter or opposite of an electron, and this is an electron, that's going to be -1. So this is a positron particle, this is an electron, and to the last, that's going to be the alpha particle, or you can just refer this as helium because they are almost the same. It contains 4 mass, and we have 2 protons and 2 nucleus. Now let's talk about the annihilation. So annihilation occurs when positron and electrons, they collide with each other, and they will basically produce 2 gamma rays. So let's say we have an electron and positron here, they collide and they will exert some gamma ray. So that is annihilation. What element will be produced if uranium-238 undergoes alpha decay? So we have our uranium-238 here, and it's going to have a 92 atomic number. So it will undergo alpha decay. So it's going to be 4,2He, or we can just write the Greek alphabet symbol. So just as normal, we are just going to solve for the value of A, the value of Z, and if we do find the value of Z, we're going to look to our periodic table and find that element symbol. So our A is going to be 234, that is his mass, and Z is going to be 90, it's its atomic number. So 90 in the periodic table is going to be what is this? Let me look up, and that it's going to be thorium. So this is isotope of thorium, it's thorium-234. An unknown element undergoes positron decay and produces neon-22. What is the unknown element? So let's say this is the unknown element, and it will be produced in positron decay, and the element that will be produced is neon-22. So solving for A and Z, so Z, let's solve for Z, that's going to be 11, and A is basically going to be 22. So they do have the same mass. So the element is going to be the atomic number 11 in the periodic table, which is going to be sodium. So this is sodium-22. Mercury 201 undergoes electron capture. What element will be produced? So we have Mercury 201 here, and this atomic number of 80. So this will undergoes electron capture, which is this. You have a negative 1 there. It's a negative 1. So this is basic. You can solve the value of A and the value of Z. So Z is going to be 80 minus 1. That's going to be 79. And now we're going to look for the atomic number 79 in our periodic table. So that's going to be gold. So this is gold 201. Also, this type of decay, it will produce a gamma ray. Those alpha decay causes the mass of an atom to decrease by 4. So this is true because we have 4 here. This is going to be mass. So if a certain element just goes alpha decay, it will basically lose atomic mass of 4. So this is true. Is the net effect of beta decay is to change neutron into a proton. So let's say we have a neutron here, and this neutron will undergoes beta decay. So I forgot the one there. Neutron have mass. So solve it for Z and A here. So let's do that. So A is going to be 1, so it does have a mass of 1, and Z is going to be here, and we're going to transform the negative 1 to the other side. It's going to be 1. So this is proton, so this is also true. Oops, I was going to write it true on the element. So this is a proton, that's going to be true. The net effect of beta decay is to change neutron into proton. Do the electron captures involves the loss of a proton? So this is true, because electron, we have a negative 1 here, so it will basically lose an electron, a proton. This atomic number is equals to the number of protons. Am I sleepy? Do gamma decay has no significant effect on the mass of the nucleus? So this is true. Gamma decay has no significant effect on the mass of any nucleus because gamma particle or gamma ray is massless, and also it doesn't contain a proton. Do positron decay causes a neutron to change into a proton? So let's say we do have a neutron here, and it will undergo a positron decay. So is it going to produce proton or other particle? So let's solve for this one. So if we're going to solve for A, that is just going to be 0, so our particle is massless. And if we're going to solve for Z, we have a negative 1, which is not a proton. So the positron decay causes a neutron to change into a electron, not a proton. So this statement is basically false. And that's it for this video. I hope you learned something, and